Greetings of the day. So myself M Venkatesh, Assistant Professor, Department of EEE. So today we are going to see the superposition theorem and its applications and understanding of analyzing the circuit DC circuits. This is the flow of presentation. So in this we are going to see the introduction, why to use the superposition theorem, as well as conditions for superposition theorem, what are the steps and procedures we need to use, so as well as we are going to discuss in these presentations along with that example circuit and practical applications and our advantages and limitations, and finally the references. So first we are going to see what is superposition theorem. That will be the introduction. The definition, which will be represents in a linear circuit with the multiple independent sources, the responses in any element in sum of the responses caused by each independent source acting alone, with all other sources kept, independent sources are replaced by their internal impedances. So we can say here, so in another way also, so which means, so when there is a multiple of source in a linear circuit, so for calculating that resultant current through any element, that will be the algebraic sum of currents that will be produced when the independent sources are acting alone while other source kept open circuited or short circuited. It will be varies, depends upon which type of source that we are going to use in that circuit. So we will see that which type of source that we are going to open circuit or which type of source that we are going to short circuit, we will see in the upcoming slides. The next, so why we need to use the superposition theorem in the DC circuit analysis. So which are used to simplify the complex network into the simple network, as well as these superposition theorem which can be applicable into that linear circuits, as well as this will be used to understand the contribution of each source in that DC circuit, in that complex circuit, because we need to know that, so what will be the contribution of individual sources through that particular element. So the current that will be contributed by that individual source through that element, that we are going to calculate by using this superposition theorem. So there is some limitations also. So first, the superposition theorem is valid only to the linear circuits, as well as by using the superposition theorem we can be calculate the currents through that particular element, but we cannot directly apply the superposition theorem to this to calculate the powers in the DC circuits. So next we are going to see the condition for superposition theorem. So there may be some conditions that will be specified to apply the superposition theorem into that linear systems. The first one is the circuit should be linear. It must be linear, as well as it should contains the independent sources. So as well as the third point is, alternatively we need to deactivate the sources. So by using these three conditions we can be analyze the DC circuits. So next we are going to see that step by step procedure to calculate the current, resultant current through the any element in that DC circuit complex network. The first, what is the step? We need to identify all the independent sources. So how many sources are there? So based on that, we need to be select the particular source, and we need to be select the particular source which is going to be active in that circuit to analyze that current flowing through the particular element due to that particular source. Next, deactivate all sources except one. So which one we are going to keep in that circuit, except that all other sources should be deactivated. So how we can deactivate it? So that should be deactivated based on that source type. The first one is, in case if it is voltage source, so we need to be short circuit. So if it is current source, we need to be open circuit. These conditions should be applied after finding the independent sources in that complex network. Next, analyze the circuit to find the effect of active source. So whatever the source is active in that particular circuit, so due to that particular source, what will be the effect on that circuit? That we are going to calculate the same procedure that we are going to repeat for all other sources too. So because as per the superposition theorem statement, we need to know that contribution of individual sources and that particular element. So while when we find the contribution of individual sources in that element, then we can find the resultant current due to that all the sources while it is active in the circuit, the current flowing through that particular element that can be calculated. If we find the contribution of individual sources, we can find the resultant current flowing through the particular element that we are going to analyze, that we are going to find so current through that particular element. Next, this process should be repeated for all sources and add the effect of algebraically to find the total response of that current. This will be the procedure and step-by-step procedure that to be followed to apply the superposition theorem in the complex network DC circuit analysis. Next, we will see that up to now we have seen that procedure, what is superposition theorem, procedure, so where we can apply the superposition theorem. Now we are going to see the example circuit of superposition theorem. So here we have one example that carries the two independent sources. One is current source, another one is voltage source, and it may consist of some resistors which are connected in such a manner like series and parallel. So we know that. So we will tell you that if the resistors are connected in parallel, if the resistors are connected in series, what are the impacts that will be created in the current distribution in the superposition complex network when we apply the superposition theorem. We will see that. So this will be the example circuit. What they have said, determine the current through the 8 ohm resistor for the circuit shown by using the superposition theorem. So here what we need to do, we need to find the resultant current flowing through the 8 ohm resistor which is present in this network DC circuit. So that should be using the superposition theorem. We need to apply the superposition theorem here. The first step, we know that what is the first step. We have found that how many independent sources are present in this circuit. Two independent sources. If the next step is, we need to keep any one source in the circuit, other source should be short circuited or open circuited, depends upon the type nature of that particular source. So first one, the step one is, we are going to consider only the voltage source in the circuit. The voltage source in the circuit. So the current source is removed. So based on our condition, if it is current source, we need to open circuited it by replacing their impedances. So impedance means we know that it will be the combination of resistance and reactance. They have not mentioned here any impedances, and that means any resistance and reactance value here. So because of that, we need to keep it as open circuited. We kept it open circuited. Now we need to find that current. So current through that 8 ohm resistor. The current through that 8 ohm resistor because of that 20 volts source, active source. So now before that, we need to find that the total current that will be delivered from that 20 volt voltage source. So for that, we know the formula I is equal to V by R. Based on the Ohm's law, so I is to find the total current that will be delivered from that voltage source. So we need to know that voltage value and we need to know that equivalent resistance value. Here we have the three resistors. Here if you take this circuit, here we have the three resistors, 2 ohm resistor, 8 ohm resistor, and that this resistor is open circuited. Because of that, it will be neglected, because we know that when the circuit is closed loop, when it forms the closed loop, that time only the current will be flows through the circuit. So unless if it is open circuited, so no current will be flows through this resistor. This resistor can be neglected from the circuit. So now only the two resistors are present in the circuit. That will be 2 ohms and 8 ohms. So it forms the circuit with the 20 volts active source. Now we need to find that total current that will be delivered from that 20 volt voltage source by using this formula. I is equal to, we know that what is the V value here, 20 divided by the total resistance. So if you take these two resistors, 2 ohms and 8 ohms, by removing this redundant resistance, that will be, this forms the series with this voltage source. If the resistors are connected in series, so we have that rule, so that should be added directly. So the similar way here we have added directly 8 plus 2. So finally when we the 10, so 20 divided by 10, finally we will get the 2 amps. So we know we got the total current that will be delivered from the 20 volt active source. But we need to calculate the current through this 8 ohm resistor. So because these two resistors are connected in series, which parameter will be gets varied? Only the voltage will be gets varied when the two resistors are connected in series. The current will be same throughout that operation. So through in this closed loop. So whatever the I value, that same current will be flows through this 8 ohm resistors too. So we can say that the I that will be equal to the current flowing through the 8 ohm resistors we kept as it is. So I that will be equal to 2 amps. So next we are going to consider only the 2 amps current source, because we have seen in that circuit diagram we had one voltage source, one current source. If we have the voltage source, we need to find the total current that will be delivered from that active source. Now we have the current source in that circuit, so voltage source will be removed. That means 20 volts voltage active source will be removed if the voltage source is removed. So what we need to do as per our condition, so we need to short circuit that particular voltage source. When we remove that voltage source, we need to short circuit it. So now we have the current source. So we now need to apply here that series resistance, parallel resistance formulas to find that equivalent resistance, because we know that methods will be used to find that current delivered from that particular active source. But here the active source is current source. We know that the total current that will be flows from that source, so that the total current is 2 amps. So directly we can apply the current division rule. Directly we can apply the current division rule. So we know that the formula for current division rule, so the I that will be equal to the total multiplication of, that means the IT that will be the total current. So we know that what is the total current here, 2 amps, and it will be multiplied with that opposite resistance divided by the total resistance. It will be multiplied with the combination of the or ratio of opposite resistance to that total resistance. When we consider the 8 ohms resistor, that there we need to find the total current or impact of the current source on this 8 ohms resistor. So when we calculate the current through this 8 ohm resistor, so which one is that opposite resistance? The 2 ohms, that will be the opposite resistance, then divided by the total resistance, that will be the 8, which where we are going to find the current, that will be included in that total resistance 8 plus 2. But here we have one more resistor too, that is connected in series with that current source, that will not be calculated, because we know that the condition when the current flows in the series resistor, the current will not be changed, only the voltage will be gets changed. Okay, so now this will be the formula that we are going to use the current flowing through that 8 ohm resistor. This formula will be called as current division rule. So IT we know that 2, and the opposite resistance that will be 2 ohms divided by the total resistance that will be 2 plus side, the 4 divided by 10, the finally we will get the 0.4 amps. That will be the current flowing through the 8 ohm resistor due to the 2 amps active source, the 2 amps active source. Now we have found the impact of 20 volt resistor, and we have found the impact of 2 amps resistor on that 8 ohms resistor. That means the current produced due to that 8 ohm 20 volts resistor, 20 volts active source, and the current that will be circulated through the 8 ohm resistor due to 2 amps current source. Now we need to find the resultant current due to the two sources on that through that 8 ohm resistor. So that will be calculated based on the current flowing through the 8 ohm resistor directions. If you take the 20 volts active source, the current will be enters in that minus, the current will be leaves from that plus. The direction of current will be clockwise. So when we consider in the direction of current in across the 8 ohms, it will be enters in plus, it will be leaves from minus. So so it is in clockwise direction. When you take the 2 amps current, so what will be that the current will be in reverse direction, so the current will be enters in minus, leaves from plus, but both the currents are opposite directions, so we can minus the least value of current from the highest value of current. So finally we will get 2 amps that will be in that forward direction plus 0.4 amps that will be in the reverse direction. So finally we can add these two, that this direction mark, this mark which will be represents the polarity of that current. If it is downwards, that will be that enters plus 2 minus in the forward bias, because of that this 2 amps current will be plus. When it is comes to the 0.4 amps current, so it will be in the reverse to that forward current. The first loop current will be opposite to the second loop current. So this indication which will be represents the minus, the polarity will be minus to this 0.4. So finally when we add these two values, so 2 minus 0.4, finally the resultant current through this 8 ohm resistor will be 1.6 amps. So this is how we can find the resultant current through this 8 ohm resistor due to that two active sources, due to the two active sources. So next we are going to see the real world scenarios, so where we can apply that practical applications of superposition theorem, where we can apply the superposition theorem. The first one is the electrical network analysis, so we can apply the superposition theorems in network analysis. Next, signal processing units, in the signal processing units we can apply the superposition theorem. And control system in automation, in the control system we can apply that superposition theorem. So next we are going to see what are the advantages and limitations it has. The first one is the advantages. If you talk about the advantages, so superposition theorem which are used to simplify the complex network, and we can be analyze that circuit by using the superposition theorem. The next one is useful in teaching and understanding the circuit behaviors. By applying the superposition theorem, we can analyze the each source in the circuit. So each source in the circuit, what will be the impact on that circuit due to that each source, that can be analyzed by using this superposition theorem. So we are claiming that that will be the advantages of superposition theorem. Next, the limitations, as we have seen in the first slide itself. So what we have discussed, the condition, the superposition theorem is only applicable to linear circuits. We cannot apply it to the non-linear circuits. That will be the limitations of superposition theorem, as well as requires repetitive calculation for multiple sources. So because if it has a multiple source like 4 sources, 5 sources, like when it is a complex network, so what would happen, for each source we need to apply the same steps to find that effect on that particular element, the current flowing through that particular element due to that particular source. We need to repeat it multiple of times. If the sources are increased, the procedure will be repeated multiple of times. So it will takes more time. So that will be the limitations of superposition theorem. So, so up to now, we have discussed the superposition theorem. So we have understood the superposition theorem. We have discussed the applications of superposition theorem and limitations of superposition theorem. And we have applied the superposition theorem in simple network. Thank you.